Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Also, hit the bell icon to get notified of new videos. Let's say a firm has chosen to use Cloud VPN for its hybrid connectivity between GCP and its on-premises network. Due to the critical nature of the workloads, they have opted for an HA VPN gateway for its SLA of 99.99%. Which of the following is true for a cloud HA VPN gateway? Option 1. 2 tunnels from one cloud VPN gateway to the same peer gateway. Option 2. You can choose one of 2 options for the peer VPN gateway: non-Google Cloud and Google Cloud. Option 3. You need to reserve 2 external IPs for the interfaces of the HA VPN. Option 4. GCP automatically reserves 2 IP addresses for the gateway interfaces. Since the question uses checkboxes, it implies one or more answers could be correct. After careful analysis of the HA VPN service, we can identify 2 statements that are true. The first correct answer is 2 tunnels from one cloud VPN gateway to the same peer gateway. This describes a valid configuration. The HA VPN gateway resource is a single object in GCP, but it has 2 interfaces. You must create 2 tunnels on this single gateway object to utilize its HA capabilities. These 2 tunnels can terminate on the same physical peer gateway, provided that peer device has 2 separate interfaces or IPs. The second correct answer is GCP automatically reserves 2 IP addresses for the gateway interfaces. This is a core, defining feature of the HA VPN as a managed service. It handles the allocation of its 2 redundant public IPs for you, which simplifies setup and ensures physical separation. What is a cloud HA VPN? Let's clarify what an HA, or high availability, VPN is. Think of a standard, non-HA VPN as a single bridge connecting your on-premises data center to your Google Cloud VPC. If that one bridge is closed for maintenance or has an accident, all traffic stops. This is a single point of failure. A cloud HA VPN is designed to eliminate this single point of failure. It's like building 2 separate bridges over the river. On the Google Cloud side, when you create a single HA VPN gateway resource, it automatically creates 2 separate connection points, called interfaces, Interface 0 and Interface 1. To achieve the 99.99% SLA, you must then build 2 corresponding tunnels from your on-premises network, one to each interface. If one bridge or tunnel goes down, traffic automatically switches to the second bridge, ensuring your connection stays up. Let's focus on the first correct statement. The cloud VPN gateway you create in GCP is a single logical resource. However, this resource is a container for 2 physically separate interfaces. To use an HA VPN gateway, you must configure 2 tunnels on it, one for Interface 0 and one for Interface 1. So, the phrase 2 tunnels from one cloud VPN gateway is factually correct. The second part, to the same peer gateway, describes a common configuration. Your on-premises peer gateway might be a single physical router that has 2 different network interfaces, each with its own public IP address. In this scenario, both tunnels from your single GCP HA VPN gateway resource terminate on that single on-prem device. While connecting to 2 separate on-prem devices is even more redundant, this configuration is valid and very common, making the entire statement true. Now let's look at the second correct statement, which is a key feature of the service. The HA VPN gateway is a managed, redundant resource. Part of what makes it managed is how it handles its connection points. As the diagram shows, when you execute the command to create a single HA VPN gateway resource, Google Cloud performs 2 actions automatically behind the scenes. First, it creates the 2 physically separate interfaces, Interface 0 and Interface 1. Second, it allocates a static external IP address from its own pool and permanently assigns one to each interface. For example, Interface 0 might get 35.1.1.1 and interface 1 might get 35.2.2.2. You cannot choose these IPs, and you do not need to reserve them beforehand. This automation is a key feature that simplifies setup. You simply create the gateway, then describe it to see what IPs Google assigned to you. Why other options are incorrect. Understanding why the other answers are false is just as important. Let's look at option 2, which states you can choose one of two options for a peer VPN gateway: non-Google Cloud and Google Cloud. This is a false simplification. The actual options for peer gateways are much more granular. You specify the type of device, for example, another HA VPN, an on-prem appliance, or AWS, and its specific interface details, so there are many more than just two options. Now for option 3. You need to reserve two external IP addresses for the interfaces of the HA VPN. This is the direct opposite of what is true. As we've established, the key feature of the HA VPN gateway is that Google automatically allocates and manages these IPs for you. Manual reservation is not part of the process, making this statement definitively false. Let's look at the gcloud command to see this in action. The command to create the gateway is remarkably simple. You run gcloud compute VPN gateways create. You give it a name, like my HA gateway. You specify the network it belongs to and the region. That's it. Notice what's missing. There are no flags to assign IP addresses. After you run this command, you can immediately run gcloud compute VPN gateways describe my HA gateway. The output will show you a section for each of the two interfaces, VPN interfaces, and inside each one, you will see the IP address field populated with the public IP that Google automatically allocated for you. This confirms that the IP allocation is a managed, automatic part of the creation process, not a manual step you need to perform. Thank you for your attendance. Please consider subscribing to the channel.